Hello, this is Dr. Embody. Today we're going to take a look at using functions to help us solve a problem. Now, the problem we've selected comes from the cartalk National Public Radio show, a little puzzle, and it goes like this. So driving along, Terry notices that the last 4 digits on the odometer are a palindrome. A mile later, the last 5 digits are a palindrome. A mile later, the middle 4 are a palindrome. A mile after that, all 6 are a palindrome. What's the odometer reading when Terry first looked at it? So the first thing to do, since this is functions, is take a look at this problem and see what function would help me solve this problem. So you should pause the video and think about it. So what function should we use? Well, how about a function that tells me if a string of digits is a palindrome or not? And we've looked at that. This problem is a simpler version of a palindrome in that we have no punctuation and spaces and things like that to look at. So we can use the palindrome function done earlier, where I can take a string, any string, in this case digits, and then look at its reverse. And if the string and its reverse are the same, by definition, I have a palindrome. Now, how might I use this to solve the problem? Well, again, I suggest you pause the video and think about solving this problem. Well, we've talked about before a useful way to first consider any problem with computing is just trying all the possibilities, what we call brute force work, and in this case it does. So if I want to try all the possibilities of the values in an odometer, then I can have a for loop, and we'd use values in the range up to a 6-digit odometer reading. And implicit in this problem is the fact that we have a 6-digit odometer, which is the common odometer in the States. All right, so what do I want to do? Well, I want to take one of those integers and make it into a string and check to see if the last 4 digits are a palindrome. How might I check the last 4 digits? Well, in this case, slicing is your friend. Now, if it comes out that it's true that the last 4 digits are a palindrome, and notice that we start with index 2 because counting starts at 0. So we have our indices 0, 1, and 2. So there's 0, 1, and then we're taking 2 to the end, because remember that the colon indicates that we go all the way to the end. So that'll be a slice of the end. If that is true, then we'll go another mile and check to see if, in fact, that's a palindrome. Now, in this case, we want the last 5 digits, so we do our slice starting at index 1, remembering that our counting starts at 0. So if that's a palindrome, again, let's go another mile and check. In this case, we're grabbing the middle 4 digits, so we start with index 1 and we go up to and not including digit 5, which is the last one. And if that is a palindrome, we'll go another mile. In this case now, we have the result we're looking for, and let's print out the original value. Okay, so let's review what we have here. We have a function which will tell us true or false if we have a palindrome. We take a string and its reverse. Now we're going to try all the possible values of I up to a 6-digit odometer reading. We first of all convert it to a string. I'll slice it starting at index 2, 0, 1, 2 to the end. If that's a palindrome, we'll go another mile and check the last 5 digits. That's starting at 1. If that's a palindrome, we'll go yet another mile, check the middle 4 digits, slice. If that's a palindrome, we'll go another mile and then check the whole thing. All those are true. All those palindrome checks are true. So let's print the mileage that we started at. Right? So we will print the I. Remember, each time along we'd ever change the I, we kept adding 1 to it. So let's take a look. Now clearly something is wrong, and let's take a look at this. Well, the first value that we came up with was a 0. And 0, 1, 2, 3, well, so what do you notice here? Well, any single digit will be a palindrome in a trivial sense. So our problem is that when we think about an odometer, we think about it having, it obviously has 6 numbers showing, and the leading ones are zeros, and I haven't accounted for that.